Code please.
Welcome to Code Please. In this channel, I try to teach you a little bit about computer programming using the Elixir language. If you find this content useful, please consider subscribing and sharing with your friends. Now let's get into today's video. I want to start this video with a disclaimer. These topics, processes and concurrent programming, although they are built into the Elixir Erlang and form the core of all things inside the virtual machine, they are advanced concepts that should be employed only when you require them. Most of the time, you will probably be able to solve a problem by using plain functional calls between modules, and should resort to explicit processes only when you really need to solve a problem using concurrency and fault tolerance. That being said, Elixir and Erlang provide a much easier experience in terms of concurrent programming than most programming languages out there, in my opinion. Not to mention the fact that the virtual machine takes advantage of all the cores in your computer's CPU by default, and even supports multiple machines working together transparently. It is in fact very possible to have some of your processes running in a different machine than the one that spawned them if you use Erlang clustering. All of this is perfectly transparent to the programming, which in my opinion is amazing. In the last video, we looked at agents and how we can easily keep state inside processes in the Erlang virtual machine. Agents are a specialization of a generic server, or GenServer, specifically tailored to have some state and manage it. But GenServers are, although more verbose, much more useful when you want to do more advanced functionality. Let's take a look at the differences between an agent and a GenServer. So one of the differences between agents and GenServers is that, for instance, agents, they have client code and server code mixed. And when I say server, I mean the process that gets spawned when we do a start link, and the process to which we are sending messages and is keeping our state. So if we take a look at this code here, we can see clearly that up until this point we are in client code, so we are basically calling a simple module function called put, and we're passing it the process identifier referenced here by the store variable, and we want to put the key value inside our state, if you followed the last video that we did. And up until this point we are in client code, so we are basically in the process that is calling the server, or the process that contains the state. And when we do agent.update, we are passing a function that will actually run inside the server process that actually holds our state. And we are asking it to take its state and basically update its state with a new key value. And then when we end this call, the agent update call, we are basically back into client code. We are back in the process that is making the call to the server. While in GenServers, this is explicitly split. So in a GenServer, what you would do is have a client call or a client function, exactly like we had for agents, but then you would send a message using this call function on the GenServer module. You would send a message to the server saying, okay, put this key and this value. And this is just basically a tuple. It can be actually anything that you pattern match, and you are going to pattern match that on a server callback, handle call. So if you use the call function, you need to implement the handle call callback on the server process, and it's in the same module, but you can think about it as like all this code is going to run on the process that is making the call, and all the handle something functions will run on the server. And the GenServer module is actually responsible for doing all this kind of wiring behind the scenes. So we are sending this instruction put key value, and then the server intercepts this message and basically pattern matches against anything that we put there. And there's a couple of other variables. So from will store the process that is actually making the call to the server, and the state is the state that the server is handling. So in this case, we are replying okay, and we are updating our state. So the code is a bit more verbose in GenServers in general, but it also has some advantages, as it clearly specifies what is running on the target process, the server, and what is running in the client, the calling process. The code itself is the same, but parts run in one process and another part, and other parts run in the server process. So let's try to implement a very simple GenServer and add some functionality as we move along. Now, because we can directly call GenServer.call and GenServer.cast, we don't need to implement our API functions just yet. So let's focus on the server for now. I'm going to define a new module called SimpleServer, and this will have three functions basically. The first function is going to be init. That will take OK as an argument, and it will just return OK and the new state. And the state is going to be like we did for the agent. It's going to be a map that is going to be able to store some information in it. And then another function that we're going to implement is going to be handle call, and it's going to handle the hello as the pattern match. We don't care about who calls this, and we get the state. And the initial state is going to be an empty map because we init our server with an empty map. And this handle call is going to basically write something to the console. Let's say call, and it's going to print out the state of the server to the console. And we're just going to do a little inspect of the state interpolated into a string, and then we are actually going to reply with world, and we need to pass in the states, and then we're just going to return a tuple reply, and the second argument of the tuple is what we want to return from this call, from this handle call, and the third argument is going to be the state that we want to propagate to the server or to keep on the server. We could modify the server as well depending on a call, like we've seen in the previous example, but we're not going to do that this time. And then we're going to implement a handle cast, and I will explain the difference in a second. Also with the low, we're going to pattern match against the low. We're going to get the state, and in this case I am going to just copy paste this line here, also print the state. I'm going to change this to cast. Oh, my bad. And we are going to return no reply, and we're going to keep the state. So a couple of notes here. We are putting these annotations on the functions, impl true. As soon as you put one of these in one of the callbacks that the GenServer accepts, and I actually am forgetting to add use GenServer here, so we can inject the GenServer behavior into our module. And we are saying that this is basically implementing something that this behavior defines. So init, handle call, and handle cast are three functions that we are expected to implement when we use a GenServer. And as soon as you put one of these, then the compiler will complain that if you miss some other ones, it will complain that you should put them all, just so it's more apparent what functions are actually implementing a behavior. Other things of note: the difference between handle call and handle cast. Handle call is a synchronous call. So you can see that we receive here who is the caller, and the caller process will actually wait to receive a reply from the server. This is all done behind the scenes, but this reply atom that we get here as the first argument of the return of the handle call is actually specifying that we are replying something to the client, and we are replying this second value. While when we do a cast, it's an asynchronous call to the process. The client doesn't really care what the reply is going to be, so we return no reply and we just pass in the state, so the server continues with that state. So having our simple server, let's give it a shot at starting it up. So we already know that this start link function, which is common to the agents because agents are basically GenServers, they return OK and the PID of the process that we spawn. So we're going to do GenServer this time dot start link, and we're going to say simple server, which is the module we want to start, and we're going to pass it OK, because this is what we specified on our init function. We could do anything at all, but this will do for now. So if we evaluate this, we can see that we started a new process. So our GenServer is actually running, which means we can just call GenServer.call, and as we can see, the server is able to reply or to handle the message with hello, which means we can do server PID, which is the process identifier of the server, and then we say, let's do a call hello. And if we execute this, we can see that call, since it's a synchronous message passing, so we send the message to the server immediately sends the message back. We get the second argument of the tuple that is the reply, in this case world. And if we do cast instead, and we do exactly the same thing, we get OK back, because the only indication we have now is that we sent that to the server and the server received and handled it, but it doesn't return anything. Even though we write on the server the state of the server, the client does not receive anything from the server in this case. And finally, if we want to stop our GenServer, it's the same as with agents. We can just call GenServer.stop, and the server is stopped. If we try to run it again, it says the process is not alive. Now let's write our client API on this server. I'm just going to get rid of this so we don't confuse ourselves. Let's call this, well, let's keep it simple server. We stopped it, so it's not running anymore. Let's create a function here. Let's say this is the server API. So let's put a comment here saying this is the server part of our GenServer, and we're going to write the client API part. And the client API is just a couple of functions that abstract away the sending of the message to the GenServer. So one that we want to implement is the start link, and we don't really care about arguments, so we can just leave it out. And in this function, we just call GenServer.startLink, which is what we were doing by hand. And we're going to introduce a couple of things here. Underscore module in Elixir means the module where we are referencing this. So it's effectively the same as putting simple server here, which is what we use to start our server using the GenServer start link function. Then we're going to pass in the initial value, so the value that init on the server accepts. We know that it's okay because it's the atom okay, because the init function accepts the okay. And then we're going to pass some options, and one option we're going to pass is the name option, and this allows us to reference our GenServer by name instead of referencing by PID, and you will see what I mean in a second. Another function we will implement is the call hello. So the only thing this is going to do is GenServer.call, and now the cool thing is that we can just reference the server by the name of the module, and since we said the name is the name of the module, we can just say call module hello. And we're going to implement another function, another client function called cast hello, and this one is just going to do cast. And that's it really. So if we evaluate this and now we try to do, we know that the start link is going to return okay and the PID, but we don't really care about the PID now because we are referencing by name. So we can just say simple server dot start link, and this will start our GenServer. And now we can do simple server dot call hello, and we don't need to do anything else. We just do this because internally the client API knows how to call the server, and the server is unique because we gave it a name. Actually, if we try to run this again, the start link, we get an already started error. So it's a guarantee that the process is unique. And we can do also cast hello, and we get okay and the server state as before, which is pretty cool. So let's stop the server so we can do some further changes. I didn't implement a stop function on the module itself. I could have, but we can just do GenServer.stop and simple server, and this will work as well. So if we run it again, it's not running anymore. One more thing that we can do, let me just get rid of this, is let's say our process, we want our process to also do some operations in the background, not just be there and react to simple messages. So let's say we want our process to every second update a value in its state. So one thing we can do is we can use process.sendAfter to self. We are going to send a message update every 1000 milliseconds, every 1 second. And we're going to specify our initial state on this process or in this server as with the value 1. So this is a map, we put value 1. And now we need to implement a function called handleInfo, and it's also part of a behavior for GenServers. So we can do handleInfo, and we're going to react to the update message, and it accepts a state. And then inside this function, what we're going to do is we're going to write to the console updating, and we are going to write the value of our state here. So state.value, and we're going to send the same message again. So after 1 second, we run the update again. So every second we're updating. And the handleInfo doesn't return a reply. It's an asynchronous call, just like handlecast, which means we just do no reply and we update our state here. And we are going to update our state by putting the state value, and we're going to increment the value by 1. So we're going to do state.value plus 1. And if we execute, if we reevaluate this and then execute, we can do simple server.start link. I'm not even going to care about the return of this. I already know it's going to be okay. And oh, I had a typo. It's actually put-s. So let's re-execute. And we started our process. And the process, as we can see, every second is update its value. And I am going to change this a little bit. So I'm actually gonna call GenServer.stop simple server, and I stopped it and it's not running anymore. So what I'm gonna do here is I'm going to modify this function to be show me, and what this will do is called show me, or send a message, send a call to show me so we can see the state back. And I'm also going to rename this function to reset, and it's actually a cast because I don't care about the result. I just want to reset the value on the state. And then I'm going to create a stop function just so we can stop it directly with the client API. And this is just GenServer.stop module. And I need to change this. It's going to match against show me, and I just want to return this state itself. I'm going to get rid of these and this, and the reset is going to set our state back to value 1. Okay, and I think if I didn't make any mistakes and I reevaluate this, oh, this is not used, so we can just underscore it. And if I start now, oh, I have a bug. Okay, the error I had was on the start link. I had an extra parenthesis here. So now if I reevaluate this and I run it, I have my simple server running, it's updating. And now one thing I can do is just simple server.show me, and it should show me the current state, value 13, as you can see. And if I do reset, it should reset back to 1. And I can also just stop our GenServer, and it's no longer running. And you can imagine that this updating in the background could be anything else, like pulling some data from the internet, for instance, or keeping a process connected to a hardware sensor and periodically read its information. There are many uses for a process to be able to do background work. And this is all very well and good, but what happens if the process crashes? I guess we should kind of monitor that process somehow and make sure that we can, well, at least restart it or log some information saying that it crashed or whatnot. The Erlang virtual machine gives you some really powerful tools, like for instance Observer. And Observer is a tool from Erlang that you can call on the interactive Elixir shell, or you can also do it from Livebook. And if you do call an observer start and evaluate this, you can see the information about the running virtual machine. And in this case, we're going to take a look at the processes that are running on our virtual machine here. And right now we don't have any of our simple servers running because we just stopped them. But if I do simple server dot start link and we execute and we take a look at the observer, we can see that we have a simple server running, and we can see the number of reductions here, or the number of operations the CPU has done on that. And it makes sense that it's rising because it keeps doing operations, it keeps updating the state in the background. And if we crash it, we could kill it from here, and we can see evaluation process terminated. So the process died, and we can do all sorts of things here. And we can also see like some cool graphs of the supervision trees, and we'll talk about supervision trees in the next video. But it's basically a link of processes that are monitoring each other. And we will get there. But for now, let's try to see if we can recreate a process that basically starts another process and gets notified when that child process dies. So we could do something about it, like spin up another one to replace it if we wanted. Let's see how we can do that. So let's write our manager GenServer. And I'm just going to copy paste code here so it's a bit faster for you to follow. But we're just going to create a new GenServer with a start link, same as for our server process. And the init function is going to be slightly different. In this case, we want to start our simple server inside this manager, and we want to attach a monitor to it. And this way, if we do this, it means that whenever this process dies, so the simple server dies, the parent process, quote unquote, will get notified about its death. And you can see the documentation here, but that's basically it. And now we're going to implement one handle cast and one handle call. I'm not going to implement the client part of the client API part of the manager, because we can just call it using the GenServer functions. But basically, I'm going to implement a call to get the server PID, and I am going to implement a call to kill the server. So it will basically call GenServer.stop of the state. The state of the manager in this case is going to be the PID of the server that we started. That's why we return server here. This is the PID of the process ID of the server process. And finally, I am going to implement a handle info function, a very special one, that is triggered by the virtual machine whenever the simple server process crashes, or we kill it actually. And that's what process monitor does. It makes sure that the virtual machine will call the manager on this function, well, we'll actually send it a message with this kind of structure, and then the manager will know that the simple server died. And we're just going to print out the server died and reason for stopping was X and X. And if we implement this, we can start the manager. And if we start the manager, we should start the simple server automatically. And we can see that the simple server is running there. And actually, if we take a look at the observer, we can now see that we have a manager that is just, kind of sitting still. on the reductions on the CPU, but the simple server is kind of increasing. So it's the simple server that is doing the work. And so now if we ask the manager to kill the simple server by calling GenServer.cast to the manager kill server, which is going to trigger this function here, kill server, which is going to tell the GenServer to stop the PID of the server. If we do this, we get this message triggered by the virtual machine. So server blah blah is dead, and the reason for stopping was normal, because we just asked the linked process, or the manager has asked it to die, basically. And now we can just stop the manager as well. And if we take a look at the observer, we can see that the manager has died indeed. Now, just a side note on these functions here, the handle info functions. Since GenServers can receive messages from anyone, and if you use send with the PID of the manager, for instance, you could potentially send it a message that it doesn't understand, because you don't have a handle info function that matches the structure of the message that you send it, and that would make the manager crash. So one good practice to do is to implement a catch-all kind of function that will just ignore any other type of messages that we don't support. And this way the process doesn't crash, and we can just move on with our lives. And another side note, since we are monitoring the server process, and as long as the manager is the one that stops it, it's all fine. But since these start links are bidirectional, if the server process crashes from some other reason, then the manager will also crash unless we trap the exits. And we can see this happening. So if I do, let me just clear this out. If I start our manager here, we see that the simple server starts. If I go to the observer and let me wait for it to show, and if I kill the server, which should be okay, right? Because the manager started the server, I also get the manager killed because they are linked. And since we don't want the manager to crash when the server crashes, because obviously the manager is trying to manage the simple server and handling, basically supervising its existence in a way, we are going to need to use a special kind of process for monitoring and handling crashes of child processes. And these are called supervisors. We will take a look at these in the next video, but basically it's what you see here on the observer. So you have a supervisor that takes care of these two processes. And there are various strategies that you can say. You can say, for instance, every time one of my children dies, I want to spawn another one just like it in its place. And this is kind of the basis of why code written in Elixir and in Erlang is so resilient, because you get this for free. Like, you can specify a supervision tree made of all these kinds of processes that are working, and you are completely guaranteed that if one of the processes crashes, its supervisor will put another one in its place doing the work. And this, for me, it's like amazing. It's like magic. And I don't know of any other programming languages that does this. So that's it for this video. In the next one, we're going to explore supervision trees and kind of look at all of what we've been doing with agents and GenServers, but from a much more simplified perspective, because we won't need to handle all of these things. We're just going to say, okay, this supervisor handles this process, and I know it's alive and it's doing its work. And you're going to see, and that's kind of the basis for the next chapters that we're going to explore eventually, like the Phoenix web framework that lives on top of the Elixir. It's basically a set of supervision trees that handle web requests to your browser. That's basically it. And knowing this, we know basically a little bit of how it works internally. So I hope you enjoyed it, and I will see you in the next video. If you liked this video, please consider subscribing and liking and sharing with your friends. It really helps the channel to grow. Thank you.